Was the universe always here? Or did it have a beginning? If so, how did it start? From ancient times, philosophers and theologians have debated these questions. But it wasn't until the 20th century that a series of stunning scientific discoveries finally enabled us to get some answers. The story begins in 1912 when American astronomer Vesto Slipher observed that light coming from distant nebulae, clouds of dust and gas in outer space, appeared redder than expected. Why was this important? Here's where your high school science pays off. Remember learning about the Doppler effect? The frequency of sound, light, or other waves changes as the source and observer move toward or away from each other. To demonstrate this, your science teacher likely played a recording of a train whistle. The pitch of the whistle lowers, that is, the sound wave stretches out as the train recedes into the distance. Well, the same thing happens with light. If a distant star or galaxy is moving away from us, the light coming from that object will also stretch out. Since in the spectrum of visible light, red light corresponds to the longest wavelengths, physicists say light that has been stretched out has been red-shifted. This evidence of redshift suggested the nebulae were moving away from us. In 1924, astronomer Edwin Hubble, working with a new 100-inch telescope on Mount Wilson in California, showed that Slipher's nebulae were not just clouds of gas around distant stars, but actually distant galaxies beyond our Milky Way. Soon after that, the Belgian physicist Georges Lemaitre correlated Slipher's redshift data with Hubble's measurements of the distances to other galaxies. Lemaitre showed that galaxies that were farther away were receding faster than those close at hand. That suggested a spherical expansion of the universe in all directions of space, as if the universe were expanding like a balloon from a singular, explosive beginning, from a Big Bang. Oddly, Albert Einstein had earlier tumbled to this idea, but then dismissed it. Einstein's new theory of gravity, known as general relativity, envisioned massive bodies altering the curvature of space, like a bowling ball making a depression on a trampoline. Einstein's concept of gravity implied that space would contract in on itself unless gravity was continually counteracted by the expansion of space. For this reason, Einstein posited a constantly acting repulsive force, known as the cosmological constant, to counter gravitational attraction. But that implied a dynamic and expanding universe, and also a beginning. To avoid this conclusion, Einstein altered his own equations by arbitrarily assigning a precise value to the force of expansion to ensure that the strength of gravity and the repulsive force exactly balanced. Thus, he depicted the universe in a perfectly poised static state, neither expanding from a beginning nor contracting toward a collapse. But then with Slipher and Hubble's discoveries, the heavens talked back. In 1927, Lemaitre informed Einstein, in a taxicab no less, about the redshift evidence for an expanding universe. In 1931, Einstein visited Hubble at the Mount Wilson Observatory and viewed the evidence for himself. Later, he announced, to his great credit, that denying the evidence for the universe having had a beginning was the greatest blunder of my scientific career. Throughout the 20th century, physicists proposed other theories that denied a cosmic beginning. One by one, new evidence showed each to be inadequate. By the 1990s, the Big Bang theory had prevailed as the best explanation for multiple lines of astronomical evidence. So why was such evidence upsetting to Einstein and to many other scientists? Princeton University physicist Robert Dicke explained, "An infinitely old universe would relieve us of the necessity of explaining the origin of matter at any finite time in the past." And so it would. But if the physical universe of matter, energy, space, and time had a beginning, it becomes extremely difficult to conceive of a physical or material cause for the origin of the universe. After all, it was matter and energy that first came into existence at the Big Bang. Before that, no matter or energy would have yet existed to do the causing. Consequently, whatever did cause the universe to exist would need to be immaterial and exist beyond space and time. To many scientists and philosophers, all this sounds an awful lot like the first words of the Bible. In the beginning, God created the heavens and the earth. I'm Stephen Meyer of the Discovery Institute, and author of Return of the God Hypothesis for Prager University.